Good morning, students. Welcome to the class. So these are few videos which are being done on the chapters of first PUC and second PUC chemistry. So here I am, Mrs. Aishwarya Ngimat. I'll be dealing with all the chapters of PU1 and PU2 chemistry. So I have divided them into two tracks. The first track involves the topics of PU1, around 14 topics are there. And the second track involves the topics of PU2, and there are around 16 topics what we have seen. So without wasting much of our time, I'm going to start with immediately the first topic of PU1, that is some basic concepts of chemistry. So some basic concepts of chemistry, what all we come across is we have seen so many aspects. Yes. First, before going to the actual concept of this topic, let us see how science had been evolved. Yeah. So science can be viewed. It is a continuing. You say it is the branch of what we study in science. We study about the nature, all the natural phenomena which are occurring in nature. And here, what we say is it is not just the natural phenomena. It is not just the study of natural phenomena, but here we study it in a systematic form. And under science we study about nature, the processes of nature, and there we come across chemistry. So chemistry is what? It is nothing but the branch of science which deals about the molecules, atoms, and their transformations, how the transformation occurs. Yes. So if you look at the molecules, and there are millions and millions of molecules. Basically, you have seen in your previous lower school classes, you have seen about different molecules, how they are being classified and all. Yes. Even you might have come across the transformations which are occurring in the nature, and the changes which occur in our day-to-day life also. Simple example I would like to quote. You might have seen when your mother putting curdling of the milk. What she does, she takes milk, she adds some amount of curd to it, and the another day, if you observe, after certain hours, if you observe, it gets converted to curd. So that is a transformation. Or during winter season, what she'll do, she'll not just take milk and add curd to it. Instead, she will warm the milk slightly and then add curd to it. Or you can add some amount of lemon juice also. Why she was warming it? Because it depends upon the enzymes which are present in it. So all these disciplines, what we are going to study, what happens, why actually milk becomes curd. This is a simple example what I'm giving. A small seed grows into a big tree. Yes, all these things occurring in the nature, they are studied under the concepts. So the branch of science that studies the preparation, properties, structures, reactions of all the materials is nothing but chemistry. So how this chemistry evolved? What actually was the history of this? So as we know today, it is not a very old discipline. See, philosopher's stone, Paris, which would convert all baser metals. That is, baser metals means what? They are iron, copper. They were going to getting converted into gold. Yes, these were some of the experiments which were done laboratorically, or you can say artificially, by the scientists in their labs. Yes, people in their ancient India, what they knew, they had knowledge of many scientific phenomena much before the advent of modern science. Yes, they were what we call them is Tattvajnana and all we call them. Yes, people are not only or I'm not talking about the entire world, but even if you consider only India, all our priests, philosophers, they knew many of the concepts much before this modern science came into existence. Yes, much big, very, very much before the modern science came into existence. So in ancient India, what we say, chemistry was called as a Rasayana Shastra, Rasatantra or Rasakriya or Rasavidya, Rasayana Shastra. So what it included metallurgy, it included medicine, it included manufacture of cosmetics, dyes, and so many things. Now, if I say metallurgy, what we feel, metallurgy is nothing but extraction of metals. It is so simple to say, students, extraction of metals. But extraction of metals involves so many huge steps, right? From starting from the first one, that is mining of the ores or minerals from the earth's crust, to the refining method. Yes, from mining to refining, all that comes is nothing but metallurgy. So here, when we say metallurgy, it starts from what? It starts from mining of minerals, mining of ores, let me say. So what is the difference between minerals and ores? Minerals means the metals exist in various forms like carbonates, oxides, hydroxides, sulfides. Those are all minerals. But from all those minerals, I cannot extract the metal very efficiently, economically. Only few minerals can give me the required metal efficiently, that is in large amount, and those minerals are called ores. So I can say all ores are minerals, but all minerals are not ores. They are not ores. So this is about metallurgy. Then it is said that it is medicine. We have seen it use of chemistry in medicine, vast growing branch, you can say. Medicine is what? Medicine is nothing but related to drugs. Yes, I can call it as pharmaceuticals. Pharmaceutical chemistry, it is growing very widely. Yes, in the field of pharmaceuticals also chemistry is involved. All the medicines what we take, all the drugs what we take are nothing but chemicals. Some are original, they are being extracted from the chemicals. Yes, so this is in the form of medicines. Then again, what I said, manufacture of so many cosmetics, dyes means what, colors, that all comes under polymers. Yes, the brush what we, the toothbrush what we use, the brush bristles what they are present for brushing our teeth, to the blanket what we take when while sleeping, everything comes under polymers. So imagine how vast this branch of chemistry is growing. So we use chemicals in all the aspects. Chemicals are being used. Yes, so it was called in India, it was called as Rasayana Shastra, right? Archaeological findings, if you see, baked bricks are being used for the construction. Yes, now also we use the same baked bricks. Yeah, then we have seen about, I'm just briefing out where all this chemistry came into existence, right? Okay, then copper metallurgy you have seen, that means there was the discovery of a large amount of copper that time, so it was called as copper metallurgy. It is nothing but during the Chalcolithic cultures of the subcontinent. There are much archaeological evidences to support the view that technologies for extraction of copper and iron were developed. Even according to Rig Veda, tanning of leather, yes, tanning of leather is being done and dyeing of cotton is being done. It was practiced very, very, very old time. See, tanning of leather and dyeing means coloring of cotton, they have all come under polymer chemistry, but very, very large number of years before only, according to Rig Veda, is nothing but during, you can say, 100 to 400 BCE. That time these practices were being done. These practices were being done. Okay, then from all these discussions, if you see, from all these about discussions, even in the field of Ayurveda, yes, for the treatment of many diseases like Chakra Samhita, it is the oldest Ayurvedic epic of India. What it describes is, it describes, I'll just mention the name also, if you want you can take it out. Yes, the name is Chakra Samhita. This is the oldest epic, Ayurvedic epic. Ayurvedic epic of India. What it contains, it describes the treatment of various diseases. The concept of reduction of particle size of metals is clearly discussed in this Chakra Samhita. Yes, extreme reduction of particle size. See, today we have studied, it is very recently the new technology has been developed. The new technology, that is nanotechnology. Nanotechnology, yes. This nanotechnology technique was being mentioned in Chakra Samhita. It was being mentioned in Chakra Samhita. So according to Chakra Samhita, what does nanotechnology means? The reduction of a material particle size of metals to a very large extent. That was extreme reduction of the particle size. Now it is called as nanotechnology. Yes, this Chakra Samhita, it also describes the use of bhasma of metals in the treatment of ailments. When the metals are being burnt, what ash comes out of it, in Chakra Samhita it is being mentioned as bhasma. It is used in treatment of ailments. So bhasma has been found to contain nanoparticles. It has been found to contain nanoparticles. Okay, so from all these above discussions, we know that chemistry deals with composition, structure, properties, and interaction of matter. interaction of matter. So all these particles, what I'm saying, those are nothing but matter particles, and they are much of use to the human beings in the daily life also. Yes, so these aspects can be best described and understood in the terms of basic constituents of matter, that are atoms and molecules. That is why chemistry, we call chemistry as the study, or you can say the science of atoms and molecules. You can call chemistry as the science of atoms and molecules. So here, since chemistry is nothing but the study of all these, so what is the importance of chemistry? Yes, chemistry has the direct impact on our lives and has a wide range of applications in different fields. Yes, it may be asked in the field of agriculture, how it is being used, in the field of food, how it is being used. So I'll just mention few of the points in each cases. In the field of agriculture and food, so here I have the first one. In the field of agriculture, you may say now, how in the field of agriculture and food chemistry is being used? Yes, some of them might give the answer also. That is nothing but fertilizers, what you say. Okay, so it has provided chemical fertilizers such as urea, calcium phosphate, sodium nitrate, ammonium phosphate, etc. So all these are fertilizers. Even it has helped to protect the crops from insects and harmful bacteria by the use of certain effective insecticides, fungicides, and pesticides, right? We use insecticides to fly off the insects or to kill the insects. We use fungicides to get rid of the fungus on the plants or the parts of the plant. And then we use pesticides to get rid of the pests. The use of preservatives has helped to preserve the food products. Like, see, we can use to food in food products. No, we use some food additives. What we call them as, we use food additives. Those food additives are nothing but to prevent the food from spoilage. One thing what I can quote is, I can quote about antioxidants. It prevents the food from getting spoiled due to oxidation of air. Then we use preservatives to preserve the food for long duration of time. Like at home, we use salt to preserve pickles, right? But what the jams, cold drinks, pickles, the meat which is obtained from the market, they are not using the same salt because the salt shelf life is less. So what they use chemicals as the preservatives. Then even you might have heard about artificial sweeteners for the diabetic patients, right? So what they can have, they can eat sweet, but it will contain less or zero calorific values. So that will not cause diabetes to the that will not increase the diabetes. So in the field of agriculture and food, this is being used. The second is about the health and sanitation. Correct? It is about the health and sanitation. Health comes when we speak about all the life saving drugs. Yes, all the medicines. So it has provided mankind with a large number of life saving drugs. Today, even dysentery and pneumonia are curable due to the discovery of sulfur drugs and penicillin life saving drugs. Yes, pneumonia, penicillin life saving drug is being used. What is penicillin? Penicillin was the first antibiotic discovered by Alexander Fleming, right? Cisplatin, what is cisplatin and Taxol have been found to be very effective for cancer therapy. Yes, for the cancer therapy. Then there are many what you say drugs which are used for AIDS victims also. Then sanitation, when it comes to the point of sanitation, we use Dettol, so many hand washers are being used, so many sanitizers are being used, right? What are they? They are nothing but they are disinfectants. They are disinfectants. So disinfectants such as phenol is being used to kill the microorganisms present in the drains, toilets, and the floors. Okay, even the same phenol at low concentration, it can be used as an antiseptic also. A low concentration of chlorine also can be used as a disinfectant. For sterilization of water, it is being used, right? For example, a low concentration of chlorine, that is around 0.2 to 0.4 ppm, is used for sterilization of water to make it fit for drinking. See, whatever the water impurity might be, if we use 0.2 to 0.4 ppm of chlorine, then it makes that water fit for drinking. Then third one is for saving the environment. Saving the environment. Yeah, so rapid industrialization all over the world has resulted in lot of pollution, right? All the poisonous gases and harmful chemicals are being constantly released into the atmosphere. So they are being polluting the environment at an alarming rate, right? So scientists, what they are doing, they are working day and night to develop substitutes which may cause a lower pollution. For example, instead of petrol, they are asking us to use CNG. What is CNG? It is compressed natural gas. So instead of, it is a substitute for a petrol, and it is very effective in checking out the pollution caused by the automobiles. Then the field of chemistry also finds applications in industries. Yes, in industries, how it finds applications is nothing but we have analytical chemistry here, right from the manufacture of different instruments to the manufacture of all the compounds what we are using day to day life. Chemistry has played a very important role in developing many industrially manufactured things. It might be fertilizers, it might be alkalis, it might be acids, it might be salts, it might be soaps, detergents, whatever it is, whatever you say, it is being manufactured in the chemistry, in the industries, right? So this contributes in a very big way to the national economy, yes or no? It contributes in a very big way to the national economy. So this is all about the importance of chemistry. So moving to now, let us try to understand what is this chemistry all about. As I said, it starts with matter, right? So what do we mean by matter? Anything or everything which occupies space and has mass is called matter. Yes, we have studied it from lower classes itself. So we are going to extend our knowledge now. For example, you can take a book, a pencil, a water or air, whatever it is. So they are composed of matter. So therefore we can say they have got mass and they occupy space. Yes, so this is matter. So matter, anything and everything in this universe which occupies space and has mass is called as matter. So you know that they have mass and they occupy space. So let us try to understand the characteristics of this matter. Okay, so classification. Based upon the nature of matter, the matter is being classified into two ways. One is the physical classification and another one is the chemical classification. As soon as we say classification, you will say matter is classified into three states: solids, liquids, and gases. No, matter is being classified into two ways. Yeah, one is physical classification, another one is chemical classification. So under physical classification, physical means what? Depending upon how they are seen from outside. Yeah, we have three states of matter. The first one is solids, then we have liquids, and then we have gases. Yes, so what are the characteristics of solids? The characteristics of solids, you already know all the characteristics. Yes, what are the characteristics? So when we talk about solids, how we define solids? They have definite shape and definite volume. So they have definite shape and definite volume. Why do they have definite shape and definite volume? Because whatever particles are present in solids, every matter consists of particles, right? Whatever particles are present in the solids, the particles are very compactly arranged. The particles are very compactly arranged. So arrangement of the particles is very compact. That means there is no space at all between the part, or you can say there is very less space. Therefore, since they have compact arrangement, or I can say they have been arranged tightly. Therefore, these solid particles, these solid molecules are also called rigid molecules. Rigid molecules. And this property which is being shown by solids is called rigidity. It is called rigidity. Yes. So since the particles are very close to each other, the interparticle distance is very less. That means the distance between the two particles is least. Rather than saying less, I can say it is least. Interparticle distance is least. So since the particles are very closely arranged, since the particles were very tightly packed, since the interparticle distance is very less, interparticle distance is least, the particles, since they are very close, the interparticle attraction, interparticle attraction, forces of attraction, what you call, is very strong, is very strong. So there is strong force of attraction. So when the particles force of attraction is very strong, to break that force of attraction, you need to apply more energy. Therefore, I can say the solids have high melting points. They have got very high melting points. Yes. Okay. Then, since these particles are not free to move, but we know that when we speak about matter, we know some of the characteristics of matter. What are the characteristics? The first characteristic comes that any matter is made up of large number of minute particles. Large number of minute particles. And those minute particles are called atoms, right? Okay. So large number and minute, they are very, very far from our imagination. Next, particles of matter are constantly moving. Constantly moving. They are continuously moving, continuously moving. Third point is, between the particles of matter, there are forces of attraction. These are very basic characteristics of any matter, whether it is solid, liquid, or gas, doesn't make the difference. Any matter, these are the basic properties. So there are large number of minute particles called atoms, and then the particles of matter are constantly moving. Then what I said, there are forces of attraction. And now you may say those forces of attraction, it varies from solids, liquids, and gases, right? It varies from solids, liquids, and gases. Here the question is, when we say the particles of matter are constantly moving, the question is how in solids? Yes, how this in solids the particles of matter will be moving, because the particles of matter in solids are compactly arranged. Here also there is movement, but the movement is not from the molecules moving from one place to another. It is the molecules move in the same place. So that movement, moving in the same place, we can say it as vibrations. So the molecule, the atoms of solids have vibrations. They have got vibrations. Yes, the movement present in solids is vibrations. And these solids, they cannot be compressed. They cannot be compressed and diffused. You cannot compress them, nor you can diffuse them. They cannot be compressed and diffused. Yes. So they are solids. They have definite shape, definite volume. They do not conform to the shape of the container. Like if I take a cube of a solid and place it in a square box, it will remain as a cube. If I place it in a glass, will it take the shape of the glass? No, it will remain as a cube only. Okay. Solids, they have also high density. They have got very high density. Mass by volume is nothing but density. So they have got very high density. Yes. Then high particles are tightly, since we say they have got high density, the particles are very tightly packed. Looking, since there are vibrations, there are motions of the particles, when we talk about motions, we come about some energy called kinetic energy. So how is the kinetic energy of molecules, particles of solids? Since the particles are not compactly arranged, vibrations are very less, therefore they have least kinetic energy. They have least kinetic energy. So this is about the some of the properties of solids, right? Some of the properties of solids. Moving to the properties of liquids. Moving to the properties of liquids. Liquids have definite volume. They have definite volume, but they do not have definite shape, but no definite shape. They have definite volume, but they do not have definite shape. Yes, he was therefore volume means what? Suppose I take 5 ml of water in a test tube, it will be 5 ml here. If I pour this 5 ml water in a glass, it will still remain 5 ml only. So what here I mean, the volume is definite, but the shape is not definite. If I'm taking a narrow test tube, I will get the shape of the test tube. If I'm taking a wide glass, I will get the water in the form of wide glass. So liquids have got definite volume, but they do not have definite shape. Looking at the arrangement of the particles are less compactly arranged, or you can say the particles are slightly loosely arranged, loosely arranged than compared to solids. They are slightly loosely arranged. Therefore, interparticle distance is present. Interparticle distance. There is some interparticle distance. Not very much as in solid gases, but there is some interparticle distance. Since there is some interparticle distance, the forces of attraction in liquids, the particles of liquids are slightly less, not very much less. Okay, they are slightly less. So looking at the melting points and density compared to solids, it is less than solids, right? So the density is less because the molecules are freely arranged. So only when we show about the solids, I show them like this, compactly arranged. Yes, I show them like this. Particles are compactly arranged. When I talk about liquids, I show the particles are loosely arranged. And when I talk about gases, I show like this. The particles are very far from each other. So they are slightly compressed, not very much compressed, but they are slightly compressed. Yes. Then when you say diffusion, they are also lessly diffused. Kinetic energy is more than solids. Of liquids. I'm speaking about the kinetic energy of liquids. It is more than solids, right? So these are some of the, since these liquids are, when you spill a liquid, what happens? The liquids are able to flow, right? Therefore, these liquids are called fluids. And they possess the property of fluidity, the tendency of a liquid to flow, and even it possesses the property of viscosity, the tendency of a liquid to stop the flow, to resist the flow. That is nothing but viscosity. Yes, so these are some of the properties of liquids. Then we have gases. When I speak about the states, it is solids, liquids, and gaseous state. But when I speak about examples, I call them as gases. Okay, so gases neither have definite volume nor definite shape. They do not have definite volume nor they have definite shape. If I take some molecules of gases in a box, they will take the volume of this box. If I let the molecules of gases in a big room, it will take the volume of the big room. Yes, so gases neither have definite shape nor they have definite volume. Yes, therefore we say they do not have definite shape nor definite volume, right? Then gases fill the containers completely. They fill the containers completely. Now, what does this mean? I'll take this point doesn't come for liquids, it comes for gases. Suppose I've taken two boxes. Okay, here I will take, in both the cases, I'll take 10 ml of liquid here, and here I'll take 10 ml of gas. When I put liquid into it, it will come around so much. Say 10 ml is so much, 10 ml of liquid. So it is not filling the container completely because the particles are being held. There are some force of attraction. Same thing if I take certain ml of gas, what happens? All the gas molecules come like this, wherever they want. Yes. So they fill the containers completely. That's my point. So they fill the containers completely. The gases fill the containers completely. Now the question arises, why do gases fill the containers completely, right? The gases fill the containers completely because the interparticle distance is least. See, you can see here, I've shown here. They are very far from each other. Since interparticle distance is least, interparticle forces of attraction, interparticle distance is highest. Yeah, interparticle distance is high. There is large distance. This is that there is large distance. The interparticle force of attraction are how? They are least. I don't say there are no attractions only. There are attractions, but they are very less. So therefore, the kinetic energy is very high. They have got very high kinetic energy. Because of this high kinetic energy, the particles of gases are moving very fast. So when they are moving very fast, they may hit each other. The molecules may hit each other. When the molecules hit each other, when particles collide with each other, what happens? When they collide with each other, there is change in the direction. Change in direction of motion, correct? Or sometimes what may happen, these particles, when they are moving very fast, they may hit the walls of the container. So when particles collide with the walls of container, what happens? They exert pressure. Yes, so they exert pressure. So how do gases exert pressure? When they hit the walls of the container. When there is change in the direction, when particles collide with each other. But these particles always move in a straight direction, not in a zigzag, in a straight direction. That means they are not moving in a wave form. They are traveling in a straight direction, in a zigzag form. That zigzag form comes when there is particles hitting each other, colliding each other. These are highly compressible, and they diffuse very easily. Example for highly compressible nature, if you take carbon dioxide and compress it, you can compress it so much that it becomes a solid, and that solid carbon dioxide is called dry ice. What it is called? It is called dry ice, solid carbon dioxide. See how much it can be compressed. Carbon dioxide gas, when you apply high pressure and reduce the temperature, what happens? It becomes a solid. That solid carbon dioxide is called dry ice. It is called dry ice, right? So these are few properties of states of matter, that is solids, liquids, and gases. Apart from that, we have come across two more states, right? One is plasma and another one is Bose-Einstein condensate. So plasma is not the common state of matter here on Earth, but it may be most common on the state of matter in the universe. Yes, this was said according to Jefferson Laboratory. Stars are essentially what? Stars are superheated balls of plasma. Please do remember this. Stars are what? They are the superheated balls of plasma. Yes, stars. They are nothing but they contain plasma at a very high temperature. So plasma, when we say about plasma, it consists of highly charged particles with extremely high kinetic energy. So it consists of highly charged particles. With extremely high kinetic energy. So the noble gases, helium, neon, argon, krypton, xenon, and radon, are often used to make glowing signs by using electricity to ionize them to the plasma state. Yes, to ionize them to the plasma state. Another one is, yes, Bose-Einstein condensate. We call it as, abbreviate it as BEC. This Bose-Einstein's condensate was created by scientists very recently in the year 1995, using a combination of lasers and magnets. Eric Kernel and Carl VM, scientists at the Joint Institute for Lab Astrophysics, yes, they cooled a sample of rubidium to within a few degrees of absolute zero. What is absolute zero? It is minus 273 degrees Celsius. So imagine how low the temperature is. At this extremely low temperature, molecular motion comes very close to stopping. Yes or no? See, the motion, the kinetic energy is directly related to temperature. kinetic energy of the molecules. You increase the temperature, kinetic energy increases. You decrease the temperature, kinetic energy of the molecules decreases. So at absolute zero Kelvin, minus 273 degrees Celsius, temperature is very less, so kinetic energy comes almost to the stopping. Yes, only when we show the kinetic energy and graph of kinetic energy versus temperature in degrees Celsius, we don't show it started from origin, we started from here. Because even at 0 degrees, there is some kinetic energy. When you extend the graph at the back at minus 273 degrees Celsius, the particles almost become motion of the particles almost becomes zero. Yes, so it comes to the stopping. Since there is almost no kinetic energy being transferred from one atom to another, the atoms begin to clump together. Yes, there are no longer thousands of separate atoms, but one super atom will be present. So a Bose-Einstein condensate is used to study quantum mechanics on a macroscopic level. Light appears to slow down as it passes through BEC, allowing the scientists to study particles wave paradox. Bose-Einstein condensate has many properties of a superfluid or a fluid that flows without friction. So Bose-Einstein condensate are also used to stimulate conditions that might exist in the black holes also. Yes, so this is all about the states of matter. This is all about the states of matter, right? So solids, liquids, and gases have mentioned some of the properties here. Very held close to each other, therefore they have got they are called rigid molecules. Liquids and gases collectively they are called fluids because both of them flow. Yes, the particles are close to each other but can move around. In case of liquids, they have definite volume but no definite shape. Gases, the particles are far apart as to those of present in the solids or liquids. Their movement is very easy and fast. Characteristics of gases. Gases have neither definite volume nor definite shape. They completely occupy the containers in which they are being placed. Yes, so this is about solids, liquids, and gases. Even we know that these solids, liquids, and gases, they can be converted from one form to another. Yes, they can be converted from one form to another. That's what I call interconversion of states of matter, and that is by the application of heat or change in temperature, I can see. So these three states of matter are interconvertible by changing the conditions of temperature and pressure. So how? By changing conditions of temperature and pressure. Yes, so how I can show it? Solid can be converted to liquid and liquid can be converted to gas. Gas can be converted to liquid. Liquid can be converted to gas. If you heat, it becomes liquid. If you heat the liquid, it becomes gas. If you cool the gas, it becomes liquid. If you cool the liquid, it becomes solid. Yes, this is nothing but interconversion. Even solid can be directly converted to gas without passing through liquid. That is called sublimation. Or gas can be directly converted to solid without passing through liquid. That is called deposition. Yes, it is called deposition. Yes, so this is by changing. Even here I have took about temperature. Even you can take apply pressure also. I have told you gas, when you apply pressure and reduce the temperature, it becomes liquid. That process is called liquefaction of gases. Even when you apply very high pressure, gas can be converted to solid also. Example is your dry ice, right? It is dry ice. So on heating, a solid usually changes to liquid, and liquid on further heating changes to gas. And there are methods also known to it. Conversion of solid to liquid, what we call it as melting. Liquid to gas, we call it as vaporization or evaporation. Gas to liquid, we call it as condensation, and liquid to solid, we call it as freezing. Yes, so there are these terms. Solid to liquid, we call it as melting, or you can call it as fusion. Then liquid to gas, we call it as vaporization. If it is a natural phenomena, we call it as evaporation. Then gas to liquid, we call it as condensation, and liquid to solid, we call it as freezing. Solid to gas directly, we call it as sublimation, and such substances are called sublimates. And gas to solid directly, it is called deposition. So these are the processes. And the temperatures at which melting occurs, it is called melting point. Temperature at which vaporization occurs, we call it as boiling point. There are different freezing points and all. Yes, so that is all the processes which come under conversations, interconvergence of different states of matter. Okay, coming to the classification of matter based on chemical ways. So chemical classification. Based upon the composition, matter can be divided into two types: pure substances and mixtures. So pure substances means what? Don't go to the technical name of the concept of the term. Yes, pure substances means what? There are no impurities in it, not like that. A pure substance, you can define it as a single substance or a matter which cannot be separated by simple methods. Or if you want to define pure substances in another way, you can say that pure substances are those which are made up of same kind of atoms or two or more different atoms in definite proportion. Now, what does that mean? Pure substances, they are same kind of atoms. Yes, if you take a piece of iron, you will have all iron atoms in it. Or is it like you will have some gold atoms in it? No, if you take a volume of oxygen gas, it will have all oxygen gas molecules on it. Yes or no? So it is made up of same kind of atoms, same kind of atoms. Or it may be made up of two or more different atoms. Like for example, you take water. Water is H2O. It is made up of two or more different atoms, but the proportion is always fixed. By atom ratio, if you see, two atoms of hydrogen and one atom of oxygen. You go across any part of the world or the universe, you will have water in the composition by atoms I'm speaking. Okay, by atoms I'm speaking, it is 2:1, two atoms of hydrogen and one atom of oxygen. So this is a definite proportion. So based on these two definitions of pure substances are classified as elements and compounds. If the pure substances are made up of only one kind of atoms, then I call them as elements. An element consists of only one type of particles. The particles may be atoms or molecules. Only one type. If you take an example of hydrogen, it will have all H2 molecules only. If you take example of iron, it will have all iron atoms only. So it is made up of only one kind of atoms or only one kind of molecules. They are said to be elements. Yes, the particles may be atoms or they may be molecules. Fine. Then, for example, sodium, copper, silver, what they are? Sodium, copper, silver are all elements, right? They are all elements. They are all metals, or you can say they are non-metals. Elements they are. They all contain atoms of only one type. However, atoms of different elements are different in nature. Yes or no? If you take an atom of gold and an atom of silver, Will they be same? No. What in case same means what? Whether the physical appearance or you can say the chemical behavior. If I talk about physical appearance, that the atom of one element may be small, the atom of another element may be large. If you take example of sodium and copper, sodium is a larger atom. Sodium has a larger atom, whereas copper has a smaller atom. So atomic size is different. Even the behavior also differs. Sodium is a highly reactive atom. It will react very vigorously. Copper, it reacts moderately. Yes. So so they have atoms of different elements. They are different in nature. This will be studying in a deep in some other theory, which we call it as Dalton's atomic theory. Whereas in some others, two or more atoms combine to give molecules of the elements. Example, hydrogen atoms. Two hydrogen atoms combine to give hydrogen molecule. Two nitrogen atoms combine to give nitrogen molecule. See, the molecule also contains same atoms. So hydrogen H2, two atoms of hydrogen. Nitrogen N2, two atoms of nitrogen. Oxygen O2, two atoms of oxygen. They consist of molecules in which two atoms combine to give respective molecules of the each elements. Moving to the next one, that is compounds. Yes, so compounds are what? Compounds may be defined as the pure substances containing two or more elements combined together in a fixed or definite proportion. In a fixed or definite proportion. Yes, the proportion might be fixed or definite. So by weight and can be decomposed into these elements by suitable chemical methods. Like for example, if you want to separate water, H2O, hydrogen and oxygen, if you want to separate, you cannot say I will heat them and I will make a hydrogen and oxygen different, right? We need some different chemical methods only for it. So they can be separated by chemical methods. Basically here also, when I said about elements, the atoms of same elements have same size, whereas the atoms of different elements, they have got different size. Yes, if I take examples like here, I can show you. Yes. Then yeah, so here. So this might be atom of hydrogen. This is atom, let me say oxygen, atom of nitrogen, atom of copper, atom of sodium. See, the sizes are different. If you take atom of nitrogen only, it will have same size. So atoms of different elements, they have different sizes. Second thing, what I want to say is, when the atoms, even these atoms may combine. So let me say I have atom of hydrogen here, the two atoms of hydrogen. Yes, these two atoms of hydrogen, they will combine to form, they will combine to form, they will combine to form a molecule. They will combine to form a molecule, right? They will combine to form a molecule. So this is what we call, it is a molecule of H2. So atoms, they combine to form a molecule. Similarly with O2 also you can show the same. Yes. So this is all about atoms. Atoms of same elements have same size. Atoms of different elements, they have got different size. When we talk about compounds, they two or more atoms of different elements combine. Two or more atoms of different elements combined here. Like for example, suppose I want H2O. So what happens here? When I want to form H2O, I have oxygen, correct? And then I have, okay, so I have Yes, so I can write here H, oxygen, H. So two or more different atoms, they can combine to form a compound. This is one molecule and many molecules become a compound. Yes. Another example, if you want to see, we can speak about another example, like you can tell me what is this? So this is one. So I'll write here. So what is this compound? It is carbon dioxide. So two or more different atoms combine, but they combine in a definite ratio. When they combine in a definite proportion, definite ratio, or you can say what we say, a fixed proportion by weight, we call it as a compound. So atoms of different elements are present in a compound in a fixed and definite ratio, and this ratio is a characteristic of a particular compound. Yes, also the properties of the compounds are different from those constituent elements. When you compare with the constituent elements like hydrogen property, oxygen property, the compound properties will be different. Like for example, oxygen is combustible, hydrogen is supporter of combustion, but the compound formed from the two constituent elements, that is water, it acts as an extinguisher of fire, right? So the properties will differ. Hydrogen and oxygen are gases, whereas the compound formed by the combination of both, it is liquid. Water is liquid, right? It is liquid. So properties differ. Hydrogen burns with a pop sound. Oxygen is supporter of combustion, but water acts as a fire extinguisher. So the properties of the compounds are altogether different from the constituent elements. From the constituent elements. Yes. So the compounds have been, see, to study these compounds in a proper manner, there were many compounds discovered. So in order to study these compounds properly, they have been classified into two types, that is inorganic compounds and organic compounds. Basically, very large number of years before, this classification of compounds was be making the study easy was being given by J.J. Berzelius. What he did, he divided the compounds into two types: those compounds which are obtained from living sources, and those compounds which are obtained from non-living sources, right? So the compounds which were obtained from living sources, he called them as organic because they were obtained from organisms. So from the living sources, it might be plants and animals. Those compounds which are obtained from non-living sources, like this stones, rocks, mountains, they were called as inorganic compounds. Yes, this was the old definition of a compounds, classification of the compounds, inorganic and organic. Today the definition is quite different, that we will study in our next class. So here try to understand, the compounds were classified as inorganic and organic. Inorganic compounds, these are the compounds which are obtained from non-living sources such as rocks and minerals. It might be any example: common salt, marble, gypsum, washing soda, calcium carbonate. Marble is nothing but calcium carbonate, limestone. All these are the examples of inorganic compounds. And organic compounds, they are the compounds which are present in plants and animals. Whatever you take, proteins present in our body are organic compounds. Carbohydrates which are required for our body, organic compounds. The fats obtained from animals, organic compounds. The oils obtained from vegetables are organic compounds. The DNA and RNA, that is the nucleic acids present in the human body, which are responsible for the transformation of the hereditary characters from one generation to another generation, are nothing but organic compounds. The vitamins which are required for the growth of the human body, that is what? Organic compounds. So to understand, the organic compounds are those which are obtained from living sources, that is plants and animals, and the inorganic compounds are those which are obtained from the non-living sources, that is rocks and the minerals. Okay, moving to the next one, that is mixtures. So this is about compounds and pure substances, and second one is mixtures. Now what are these mixtures? Based on chemical composition classification, this is the second term. So what are mixtures? Now the combination of two or more elements or compounds which are not chemically combined together and may also be present in any proportion is called a mixture. I'll give you a simple example. I say air is a mixture. Why do I say air is a mixture? When we talk about the air, atmosphere consists of air, right? And that air is nothing but it contains different gases. It might be carbon dioxide, oxygen, nitrogen, it might be a carbon monoxide. Yes, all these gases are present. Tell me, do these gases react with one another? No, they do not react with one another. So only oxygen is present as oxygen, carbon dioxide is present as carbon dioxide, monoxide is present as monoxide, nitrogen is present as nitrogen. So this is nothing but a mixture wherein the constituents do not react chemically. The constituents do not react chemically. Yes, and they may present in any proportion. In our area, oxygen level might be more because of the presence of large amount of, because my area is being surrounded near the forest area. Yes, so carbon dioxide is less, I may say. If you see heavily populated area or heavily trafficked area, there might be less amount of oxygen and more amount of carbon dioxide because there are less number of trees. So proportion might be anything. Another example what I can give you all is milk. You can see the various, if you take different companies of milk, amount of water level present in that milk is different. Not only milk, let me take examples of alloys. Have you heard about alloys? We define alloys as the mixture of two or more elements. The proportion of the elements what I take, it differs. Yes, that is nothing but mixtures. That is nothing but mixtures. So mixture is what? It is a combination of two or more elements or compounds which are not chemically combined together, and they may be also present in any proportion. Examples of mixture are milk. When you add water to it, milk does not react with water chemically. It will only increase the volume of the milk, right? Seawater, it is mixture of so many salts. So many salts are present. They do not chemically react. Petrol, it contains so many constituents. Lime water, calcium hydroxide with water is nothing but lime water. It is a mixture. Paint, glass, cement, wood, all these are examples of mixtures. When we study these mixtures are being divided into two types: homogeneous mixtures and heterogeneous mixtures. So what are homogeneous mixtures? In homogeneous mixtures, the components completely mix with each other. Yes, if when you say it as homogeneous, it has uniform composition. I'll give you a simple example. You take a glass of water and add lime juice to it and shake it well. When you add lime juice to it, divide that glass of water into three. Do you think only the first glass of water will have lime juice and then the next glasses won't have? No. The lime juice mixes with water uniformly. Such mixture is called homogeneous mixture. Even the example what I said, alloys, they are also homogeneous mixtures. So mixture of sugar solution. You take a spoon of sugar, add it to a glass of water, you will have the sugar particles which have distributed uniformly throughout the water. So the same sweetness is obtained when you start drinking it in the beginning or drinking it at the end. Or is it like only at the end there is sugar sweetness? No. Yes, that is homogeneous mixture. What is heterogeneous mixture? Heterogeneous mixture, it is said to be a heterogeneous if it does not have uniform composition. You take oil, spoon of oil, and put it in a glass of water. What happens? Oil being less denser, it will float only on the upper surface. You take it, you place that glass of water into another glass. First oil separates. At the last part of the glass, we will not have any oil. We'll have only water, right? So that is heterogeneous mixture. So it does not have uniform compositions throughout and has boundaries of separation between the various constituents. So different constituents of the heterogeneous mixture, you can see them with the naked eyes. Example, iron filings, sulfur powder are mixed together. The mixture is said to be heterogeneous. It has grayish yellow appearance and the two constituents, iron and sulfur, can be easily identified with the naked eye. Yes, so composition is not uniform. One more example, mixture of salt and sugar or grains and pulses with some dirt, that is often stone pieces are present. That is heterogeneous mixtures. So these mixtures, they can be separated by physical methods, whereas compounds require chemical methods. Mixtures can be separated by physical methods. It can be simple hand picking, it might be filtration, it might be crystallization, or it might be distillation. So mixtures are being separated by physical methods, whereas compounds need to be separated by chemical methods. Yes, they need to be separated by chemical methods. Differences between compounds and mixtures. Compounds. In a compound, two or more elements are combined chemically. In a compound, the elements are present in a fixed ratio by mass. This ratio cannot change. Compounds are usually homogeneous, that is, they have same composition throughout. In a compound, constituents cannot be separated by physical methods. They require chemical methods. In a compound, the constituents lose their identities. That is, the compound does not show characteristics of the constituent elements. Very important characteristics, I have clubbed them. Mixtures. In a mixture, one or more elements or compounds are simply mixed and not combined chemically. They are mixed physically. They are not combined chemically. In a mixture, the constituents are not present in fixed ratio. It can vary. The ratio can vary. Mixtures may be either homogeneous or heterogeneous in nature. The constituents of the mixtures are being separated by common physical methods. What are those physical methods? If they are visible to the naked eye, we can use simple hand picking, or by filtration, crystallization, distillation, and all, or even sublimation. In the mixtures, the constituents do not lose their identities. That is, a mixture shows the characteristics of all the constituents. And here, this is the classification, a slight, what you can say, I have made a slight attempt to club everything, flowchart. Matter, physical and chemical classification we have. Based on physical classification, we have solids, liquids, and gases. Even we have a plasma and Bose-Einstein condensate. Chemical classification, pure substances and mixtures. Under mixtures, we have seen homogeneous mixtures and heterogeneous mixtures. Under pure substances, they are being classified as elements and compounds. Elements, metals, non-metals, and semi-metals, that is metalloids, that will be taking up in the next classes. And then compounds, there are inorganic compounds or organic compounds. So with this brief discussion, we have completed half part of this topic. The next half I'll be taking up in the next slide. Hope you have understood all the concepts what I have discussed. The same questions will be involved in our MCQs what we'll be discussing further. Okay, thank you.